Assistant Professor Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the structure, operation and characteristics of MOSFET. Okay. What is MOSFET? That is, it is a metal oxide semiconductor field effect transistor. It is a type of transistor where the metal oxide semiconductor. We are going to see the understanding, how the understanding of MOSFET structure and how we are going to analyze the operation principles and identify the characteristics and exploring the biomedical applications in this. Okay. Why this topic is important? Why this MOSFET, that is metal oxide semiconductor field effect transistor, is important is that in real world biomedical problems, that is CMOS based implanted medical devices and biosensors for continuous health monitoring. That is CMOS based implantable medical devices is that CMOS, that is complementary metal oxide semiconductors. Okay, it will be a very smaller in size, and this is very helpful in implanting with the medical devices for the biomedical applications with medical devices and the biosensors. With biosensors, that is biosensor is specifically used for identifying the vital parameters of a human body. Okay, for continuous health monitoring systems, which the patients who require the continuous health monitoring systems, this implantable medical devices with the help of biosensors, it will be very helpful for the continuous health monitoring. See, generally we know that the elderly patients in our body and the chronic disease patients are very specific about these continuous health monitoring. So with this implantable medical devices with the help of MOSFET, right, this continuous health monitoring is feasible and it will be very helpful for the patients. Okay, who is affected? To whom we are going to design this device, that is CMOS based metal oxide semiconductor implantable device. Patients needing implantable monitors for chronic conditions. Okay, the patients, as I told you already, the chronic patients like the cardiovascular disease patients, right, and it is like for the cancer patients and for the dental issues. For these type, we can use these implantable monitors, and specifically for this cardiovascular disease patients, right, we can implant with the help of pacemakers. A pacemaker is a implantable medical device where it pumps the heart by itself, right. It is specific, and we can monitor it by another device, and the patients, the attender or the clinicians can monitor the patients who is implanted with the pacemaker. Okay, likewise clinicals treating patients with chronic disease, as I told you already, the patients who requires this implanting device and the chronic disease patients are very helpful with this CMOS MOSFET implantable medical device which helps in the continuous health monitoring. Medical device industries developing implantable technologies nowadays. It is developing in a very vast area where these implantable devices, it will be very helpful for the patients and even for the attenders or the clinicals to identify how the patients are recovering, or how the patients are day by day, how the development of the patient can be clearly identified by using these implantable devices, which is very helpful for them. Okay, impact if not solved. What all the impacts we are going to get? Increased power consumption in implantable devices. See, once this implantable device is not properly designed or properly incorporated into the patient's body, right, the power consumption may increase, reduces. Since the power consumption increases, the device lifetime will also be reduced. Okay, limited functionalities and reliability of implants. See, if since we are going to implant a device, it should give a minimum of an output which the clinicians require, right? It does, if it is works for a certain time and it gets switched off or something like that, if it does not get works, then it is not an easy task to remove it again. Okay, since if it is a pacemaker, for example, if we take the pacemaker, right, it will not be, it's not very easy for the clinicians to remove it frequently. So likewise, the system, that is the functionality of the implantable device, should be very accurate and very appropriate, and the functionality should be very it should be very good in accuracy too. So if it is so, this can be implanted to the patients to identify the continuous health monitoring. The continuous health monitoring can be done very easily and in a very high performance way. Okay, MOSFET in implantable medical devices, how accurate it is and how high performance this MOSFET gives. Enabling ultra low power. It gives enabling ultra low power. The power consumption of the device is very low. Okay, it is designed in such a way that with the help of CMOS based implanted devices. CMOS structure, that is complementary metal oxide semiconductor structure. This MOSFET requires only a ultra low power device. It gives high performance biosensors for continuous patient monitoring and improves healthcare outcomes. Since we are monitoring the patients day by day, minute by minute, hour by hour, so since we are monitoring, likewise the healthcare outcomes is developed in a very vast, in a very high percentage. Okay, it has been very high improvement in developing the patient's recovery. Okay, next, need for the solution. What is the need we go for this type of implantable devices with the help of specifically the MOSFET? Okay, limitations of JFET and BJT. We have a minimum amount of limitations, like some limitations. So likewise, since we have some limitations in JFET and MOSFET, we are moving on to the JFET and BJT. We are moving on to the another type of transistor called the MOSFET. High power consumption in integrated circuits, whereas the JFET and BJT has high power consumptions. Limited scalability for VLSI applications. Limited scalability for VLSI applications. Gate leakage current in high frequency operations. These are the limitations we have in the, when compared to JFET, MOSFET. BJT and JFET have these type of limitations. Implantable device challenges. What are the implantable device challenges we have in JFET and BJT is that limited battery lifetime. As I told you already, if the battery lifetime and accuracy and all those stuffs is very high, the accuracy will be also very high. It's okay. Limited battery life and chronic implementation implants. Power constraints restricts functionalities. Power constraints restricts functionalities. Power, if it is it consumes high power, right, the functionality of the equipment will be, device will be very minimum. Okay, frequent surgical replacement needed. Okay, as I told you already, if this occurs or this device requires a high power or a high power, if it requires a high power and if it has a minimum power battery backup, no, this device will be in a situation to replace it by a surgical system. Okay, next is what are the technology gap we have. Need for ultra low power operation. Need for ultra low power operation. We have to develop it for an ultra low power devices. Miniaturization of biomedical implants. If the size of the device is very high, no, it will be bit complicated, or it will be suffocating for the patients to use it. So miniaturization of biomedical implants. And high performance with minimal power. High performance with minimal power, it has to be developed in the future, the MOSFET devices. What are the advantages we have in the MOSFET is that ultra high input impedance. Ultra high input impedance is given, low power consumption is provided, and excellent scalability. VLSI integration, billions of transistors has been integrated in a MOSFET implantable device. So the low power consumption is acquired, and it has an high input impedance where no gate current is provided. Okay, these are the needs for the solution. Why we need this MOSFET for the implantable devices. Thank you.